What kinetic energy must a proton possess to split a deuteron H2 whose binding energy is given? So if we look at the disintegration of deuteron alone, so you have this deuteron and you give some binding energy and then it splits into one proton each. Now this binding energy, so it needs to be provided some energy in order to break. So it is provided in the form of kinetic energy of this proton, which is what is causing the split in deuteron. So the proton is striking this stationary deuteron atom, and in order to possess the minimum kinetic energy to split, it will be a perfectly inelastic collision and then everything will be moving together. And for this particular condition, we just derived in 6.271 that the minimum energy of this striking particle should be greater than equal to m plus m by m into q, where q is the q value of this reaction, standalone reaction, and m is the mass of striking particle and capital M is the mass of nucleus. And in this particular case, we are given binding energy. So we know binding energy is negative of q value. So this is the binding energy of the whole nucleus, where everything splits apart. So for this reaction, the binding energy is negative of q value. But since we are talking about mod, this equation holds true if we just replace q by EB. So our answer, the minimum kinetic energy needed by the proton is greater than mp plus md upon md into EB. So md is mass of deuteron, this is mass of proton. So Tp must be greater than equal to 1 plus 2 by 2 into 2.2, which gives our answer 3.3 mega electron volt.